Hello and welcome again as we consider yet another multiple choice question for IB Chemistry, which is an example of an amphiprotic species. Well, of course, the term amphiprotic refers to any species that's capable of accepting a proton and also capable of donating a proton. Put another way, an amphiprotic substance is one that can behave as both a Bronsted-Lowry acid and as a Bronsted-Lowry base. Now, the term amphiprotic is similar to and related to amphoteric, but of course there's a difference between these two. And I explored this topic in a previous video, and if you're interested in looking at that video, you should click on the card above. But let's look now at the answer to this question. And with an amphiprotic species being one that can accept and donate a proton, it really shows how simple this question is, because once you know that definition, you already know the answer. Because it involves accepting protons, and of course, most important for this question, for a species to be amphiprotic, it must be able to donate a proton. Now, how could it donate a proton if it doesn't have one in the first place? And Al2O3 doesn't have a proton, CO3 negative, no proton, and same for P4O10. The only species here that has a proton is HPO4 negative, and it can donate that proton and become PO4 negative. And in that sense, it can behave as a Bronsted-Lowry acid. Now, you don't need to consider if it can behave as a base, but if you do want to see how it can behave as a base, then you can think of how a proton could be added to this, and then it would become H2PO4 negative. So HPO4 negative can behave as a Bronsted-Lowry acid here, donating its proton, and as a Bronsted-Lowry base here, accepting a proton. And if it can behave as both an acid and a base, Bronsted-Lowry acid and a base, then such a species is deemed to be amphiprotic. And of course, the answer to this question is D.